Okay, so let's continue our class here. Alright, so tadi kita stop dekat auto decrement. Okay, so the auto decrement also called known as a post decrement. Why post decrement? Because you need to uh, decrease your address first that pointed by your pointer register, and then after you decrease the what we call the address, then after that you load or you store the data to that address. Compared to post increment, you store or load the data to your what we call here to your memory, to the address first, and then after that you increase your pointer register value. Okay, so that's why we have the pre-decrement and as well as a post increment. Alright, so this is the what we call here, this is the auto increment and decrement of the pointer register for the LD instruction. Okay, so for the LD, this is for the LD lah. Then we have a ST. Okay, for the LD, you see here, all of the pointer register have the post increment and pre-decrement, except that, okay, for the Y and Z, there are another instruction called a displacement. Okay, this one is LDD is load from displacement. Okay, so what is the what we call here? What is the difference between LD and LDD is, okay, for the LD, okay, kita look one by one lah. Yes, there is a post decrement and pre-increment. Betul. Okay, let's look at one by one of this instruction here. What this instruction do? Okay, kalau you use this one here without the plus or minus signs dekat sini, LDRNX. So what happen is after loading location pointed to by X, the X value, okay, your what we call it, the pointer register X value stay the same. Okay. Lepas you load the data, your X value stay the same. Okay. And then if you're going to use the LDRNX plus, okay, so this one here we call it as a pre-increment. This one here we call it as a post increment. Okay, so for the post decrement and pre-decrement that Chua Sin Lun asking is no such thing. Okay, kita hanya ada post increment and pre-decrement aja. Okay, no post decrement and pre-increment. Right? Okay. For this one here, for this instruction LDRNX plus, okay, after loading, okay, if you see here the function here, after you load the location pointed to by X, and then the X value is incremented. So that's why we call it as a post increment. Okay, because you load the value first to the address, and then your pointer register incremented by 1. What about this one here with the minus X? Okay, minus X, the X, okay, your pointer register address is decrement, then the location pointed to by X is loaded. Okay, so that's why this one we call it as a pre-decrement. Kamu tolak dulu dia punya address, and then after that barulah you load that data to that address. Okay, Y and Z also have the Y plus minus Y. Okay, this one also have Z plus minus Z. Okay, and then we're going to see the LDD. Okay, so this LDD instruction only valid at pointer register Y and Z only. Okay, for this one here, for the LDD, after loading location pointed to by Y plus Q, Okay, the Y stay the same. Contoh lah. Okay, I put the contoh here. LDD R16 Y plus 5. Okay, let's your Y now point to address 100. Okay, so what happened is, after you do this, this what we call this instruction, you execute this instruction. Okay, what happened is you go to address 100 plus with 5, which is address 105. Go to the address, take that the value and put to your R16. But okay, after you put the value to R16, your Y remains pointed dekat address 100. Okay, so the Y stay the same. No change to your Y. Sama juga dengan Z. Okay, so you load the location pointed to by Z plus Q, then Z stay the same. Okay, so these are the difference between X plus minus Y and Y plus Q. Okay, the Q is in decimal. Okay, the Q is in decimal unless you put the symbol. Okay, if you put this symbol, so hexadecimal lah. If you put 0x, then it is a hexadecimal as well. If you not put any symbol in front of this value here, in front of this number here, so this become your decimal number. Okay, let's look at the contoh kat sini. We have a few contoh. Kita look one by one. Okay, write a program to clear 60 memory location starting at data memory addresses 60. Okay, so starting dekat address 60, you're going to what we call here erase, put 0 until this is until what addresses here? 6F. Okay, so this is a 16 location starting from 60 to 6F. Okay, first by using the increment Rn, and then the B by using the auto increment. Okay, so first what you're going to do, okay, so we use the looping lah. Okay, we use the loops. Okay, what is our loop punya counter value? So since you're going to clear 60 memory, so the loop counter is 16 lah. Okay, so that's why this is your counter. Okay, load I R16 with 16. Okay, since we are going to use the indirect addressing mode, so we need to what we call here, we need to pilih lah. Okay, choose either we are going to use the pointer register X, Y, and Z. Okay, so in this example here, we're going to use the pointer register X. Okay, since our pointer register X is the default value is 0000, so now you need to make sure that the X point to what address? The starting address here lah, which is 0060. Okay, so this is your starting address. So how to do that? Okay, so how to do that? By load the value to your SL and XH. Okay, so this belong to SL and this belong to XH. Okay, so load I XL with 0x60 and load I XH with 0x00. So what happened after you execute this instruction here? X now point to address 0060. Okay, any question? Ada soalan tak up until here? Okay, next. Load I R20 with 0. Kenapa? Why we going to load 0 to R20? Because in this question here, it asks you to clear the value. Okay, clear the memory address. So clear is 0 lah. So you need to have a 1 GPR with a 0 value. So that's why load I R20 with 0. And then we start to store lah, STXR20, and then followed by increment SL. So increment your SL so that your SL now point to address your, okay, akan jadi 0061. Okay, decrement R16, so R16 now become 15 and branch not equal. So this process will keep repeating until your R16 equal to 0, and it will exit this loop here. Okay, this is by using the increment Rn. Okay, this instruction increment Rn. Okay, B by using auto increment. Okay, yang ni samalah. Okay, first you load your counter register, sama. Okay, initialize your pointer register so that your pointer register point to your static address, also same. And then load your R20 with 0. Okay, so that you have the value 0 inside of your one of your DPR, also same. Okay, the difference is kat sini. You see STX plus R20. Okay, instead of you use 2 instruction kat sini, okay, you reduce it by using 1 instruction only. Kalau kat atas ni you see here, you use 2 instruction, but this one you use only 1 instruction. Okay, decrement R16, of course lah, you need to decrement your counter until lah, and then branch not equal. If your R16 not equal to 0, it will keep looping. So, any question? Ada soalan tak? Up until here. Okay, so this is register indirect with displacement, macam yang I told earlier. Okay. So, this is the syntax. Okay, so every time you see the word D at the back of your instruction here, means that this belong to displacement lah. Okay. After you did the displacement, your pointer register will stay the same. Okay, not change. Okay, kamu punya pointer register value not change. Okay, so let's look at this example. Okay, this is an example, or this is the type of question that will be asked in your final exam of your test. Okay, let's look at this soalan dahulu. Okay, determine the result for the registers and memory addresses by filling in all empty boxes as provided after the execution of the following instruction. Okay, so these instructions are executed sequentially. Okay, what is executed sequentially? Apa maksudnya kat situ? Okay, any change from the previous, any value that change from the previous instruction, okay, will be used in the next instruction. Okay, that is executed sequentially. Okay, of course, we need to do line by line, okay, from top to the bottom, but the value that a change at the previous instruction will be used in the next instruction. That is executed sequentially, because sometimes you will see not executed sequentially. Okay, so this one here, if the not executed sequentially, means that the value, the register value or the address value tak berubah, no change. The value, no change. So you need to take the initial value. Okay, for execute sequentially, you need to take the current value. Okay, based on the previous punya instructions. Okay, so let's look at this, what we call here, this question here. Okay, so you have a register. So this is the value inside of your registers. Okay, this is the value inside. This is your register, your GPR with value, and this is your memory, your RAM. Okay, so first we do this one here, LDR20Z. So what happened? LDR20Z. What happened after you execute this instruction? Okay, what is Z? Anyone? Siapa nak tolong? What is your Z? Okay, so every time you come across this kind of question, first you need to identify your pointer register. Okay, so this is your GPR. So R20, R21, R22, R23, and this one R30 and R31. So you know that all. So this one is your Z pointer register actually. Okay, which is your Z pointer register. It is a 16-bit. Okay, 16-bit wide consists is a combination of R30 and R31. Okay, so make sure lah dia punya kedudukan is correct lah. Which one belong to low byte, which one belong to high byte. So in this question here, okay, R30 is 14 and R31 is 03. So you know that, okay, now Z, the pointer register Z pointed to what address? 0314. Okay, so now you can answer this question here. Okay, LDR20Z. What you're going to do is go to the location, to the address that pointed by Z, which is the address 0314. Take the value and put to your R20. So you go to address 314. So this is your address 314. Take the value. So R20 now will have what value? 6C. Okay, so here, okay, in this what we call it, in this question here, you need to fill in this table here. Okay, so this one here, okay, you change kat sini daripada 00, so now it become 6C. Okay, so you finish the first instruction. Okay, next, the second instruction, ST minus Z. Okay, you see here, the minus is in front of your Z. What happened? This is a post apa ni? Post decrement, because you need to decrease your address Z, and then after that, store to that location. Okay, so what is your Z? Z, our current Z, okay, Z kat sini sekarang ini pointed to address 314. Okay, so what you're going to do is, after you execute this instruction, Z now, you need to minus with 1, so Z point to what address? So 0313, and then what you're going to do? Store the value from R21. What is the value from R21? AC. This is R21. AC. So this value R21, you take this value AC, store to address 313. So this one here, no longer D7, dia akan jadi AC. Okay, next. What are you going to do? Okay, next we go to the next instruction lah. Okay, LD R22Z plus. Okay, so what happened? What are you going to do there? Here, you're going to load the data from address pointed by Z to the R22, and then after that, you increase your pointer register by 1. So R22. Okay, what is the current pointer register address? Siapa nak tolong? Is it 314 or 313? Okay, 313. Okay, because we executed sequentially, so we need to take the value from the previous instructions. Okay, so 313. So you go to address 313, which is AC. Okay, take this value and then put to R22. So R22 now ada value AC. So tukar yang ni dia akan jadi AC. Okay, next, what happened to your Z? Because this is Z plus, means that this is post increment. Okay, then Z increases by 1. Okay, so Z point to new address 0314. Okay, next. STD Z plus 2 R23. What happened here? You're going to store value from R23 to the location that point to by Z plus 2. Okay, so Z plus 2. So Z plus 2, what is the location pointed to by Z plus 2? What is your current Z? Z point to the address 314. Betul tak? Okay, so you plus with 2. So now Z point to 316. Okay, so you take R23, which is a BC. Okay, and the store to location at 316. So this one here become BC. Okay, so this value here must be in hexadecimal. Semua value ni in hexadecimal. Okay, and then what happened to your Z? Is it your Z now point to 316 or still pointed to, so I tulis macam ni, 0316 at address 0316 have value BC. And what happened to your Z? Is it your Z pointed to new address 316 or remain at 314? Okay, so your Z remains at 314. So you ni lah, you fill in the table. Okay, so R20 ada 6C, R21, because this one no change, so you just put no change lah, AC, and this one AC, this one a BC, and your Z also, after you did all this process there, your Z also no change, so you just put 0314 lah. Okay, at address 312 5E, 313 AC, 314 is 6C, 315 is 7A, 316 is a BC, and 317 is 34. Okay, and then you get total 8 marks. Okay, I love this kind of question because why? Because it's easier for me to do marking. Okay, just look at this value here. Okay, if the value is different, then you get wrong marks lah. Okay, you get 0 mark lah. If the value is same as the jawapan, so you get the full marks. Okay, this one is typing error. Yeah, this one is typing error. Okay, only 1 comma kat situ. Okay, any question? Ada soalan tak? Okay, if no question, so I need you to do this individual assignment. Okay, make it as your individual assignment. Okay, so nanti at the end, you need to fill in this table again lah. So your table should be, nanti you have the registers. You have R23, R24, R25, R26 until R29, and then you need to fill in the value lah, as well as your memory. This is your memory punya table. Okay, starting from 410 until 416. Okay, and then give the value for each of the memory as well as your register. Okay. Any question for the direct, indirect, and register addressing modes? Ada soalan tak? Okay, if no question, I think we'll stop here. Okay, we'll continue next week.